Hello there, I'm Andy from the Engineers Academy, and in today's experiment we're going to be measuring the viscosity of synthetic oil at various different temperatures. Now, the piece of apparatus in front of me here is called a Redwood Viscometer, and the way the Redwood Viscometer works is that we have a vessel in the centre where we're going to place the oil, and we're going to time how long the oil takes to drain through a small orifice in the bottom until we collect 50 millilitres of the oil. And as mentioned, we're going to do this at various different temperatures. So around the outside of the vessel, we have a water bath. Looking more closely at the main components of the Redwood Viscometer, we can see that we have the water bath around the outside. In the centre, we have the vessel where we're going to place the oil. And if you look very closely at the centre of the vessel, you'll see the small orifice, and that's where the oil is going to drain through. There's actually two different types of Redwood Viscometer. The one we're using here is Redwood 1. But there's also Redwood 2, where the orifice in the centre is somewhat larger, and that's for measuring higher viscosity fluids. So now I'm going to set up the Redwood Viscometer for our first viscosity measurement. So in this first experiment, we can see that the temperature of the oil in the vessel is at 40 degrees. So I'm going to lift the plug that's covering the orifice, and then we're going to time how long it takes to collect 50 millilitres of the oil. So we're up to 20 millilitres. Now we're at 40 millilitres, and it's important to point out that what we need to use as our reference is the bottom of the meniscus, so the bottom curve of the fluid. Okay, so as we get close, I need to get my eye line in line with the index mark. That's at the top of the meniscus. And there we are at the bottom of the meniscus. Okay, so for this test, the temperature of the oil is at 55 degrees C, as we can see on the thermometer here. So we're going to lift the plug, we're going to start the stopwatch and time how long it takes to collect 50 millilitres of the synthetic oil. As we would expect, the oil appears to be flowing more quickly through the orifice because as the temperature's increased, the viscosity has decreased slightly. So already we're at 20 millilitres. We're just coming up to 30 millilitres and the temperature of our oil is still at 55 degrees. Now we're just passing 40 millilitres. And as we come close to 50 millilitres, I need to ensure that my eye is in line with the index mark. And there we have 50 millilitres. So in this final round of our experiment, our oil is now at 76 degrees C. So we're going to repeat the test one last time so that we have 3 points of comparison for the viscosity at different temperatures. Now this time we would expect the oil to drain through much more quickly because the higher temperature has reduced the viscosity of the oil. So already we're at 20 ml. We're just passing 30 ml, and a quick check of the temperature of our oil, we can see that it's still at 76 degrees. Okay, so we're just passing 40 ml. And as we come close, and there we are at 50 ml. Now that we have our 3 viscosity readings in Redwood seconds, we can now convert them to a more usable form. Now the website that we're looking at here is Cole Palmer Scientific Experts, and they manufacture various different test equipment including viscometers. Now on their website they have a table which can be used to convert Redwood seconds into kinematic viscosity. So we have a column here for Redwood 1, which was the device that we were using, and we have a column here for kinematic viscosities in centistokes. Centistokes is the same as millimetre squared per second. Now when we get to the higher viscosities, what we notice is that the increments between the Redwood seconds become fairly great. So here is an example, we go from 253 to 338 to 423. So it then becomes a little more difficult to get an accurate conversion into centistokes. So what I've done is copy this table into Excel in order to produce a conversion graph. So over on the left hand side we have the 2 useful columns. We have the Redwood seconds and we have the kinematic viscosity in centistokes. And I've plotted these on an XY scatter graph up to Redwood seconds of 360 seconds. The reason I've chosen 360 seconds is because our highest reading was 5 minutes 20 seconds, which is the same as 320 seconds. So I've set the axes to maximise the space for our conversion graph. To the right of the graph, I've extracted the information from our experiment. So we did a test at 40 degrees C, we did a test at 55 degrees C, and we did a test at an average of 75 degrees C. So at 40 degrees C, our test took 5 minutes and 20 seconds, or it took 5 minutes and 20 seconds to collect 50 millilitres of oil. 5 minutes and 20 seconds converts to 320 seconds. At 55 degrees, the test took 3 minutes and 8 seconds, which is the same as 188 seconds. And the third test at 75 degrees C took 1 minute and 37 seconds, which is the same as 97 seconds. So all that's left to do is to use our conversion graph, first of all, to convert 320 Redwood seconds into kinematic viscosity in centistokes, or millimetre squared per second. So on our axis then, for Redwood seconds, all we need to do is track upwards until we strike the conversion line. Once we strike the conversion line, we track to the left. So in this case, we can see, with each of these increments being 2, we have a kinematic viscosity of 82. We can repeat for 188 Redwood seconds. So we have 180 and we have 5 increments up to 200. Therefore, each increment this time is 4 seconds. So we go along 2 squares to 188. We track upwards until we strike the line, and then we track across, noting that our viscosity this time is 48 millimeters squared per second. And finally, 97 seconds. We have 80 seconds, with each square being 4 seconds. So here we have 96. So tracking upwards until we strike the line, we can see that that yields a kinematic viscosity in millimeters squared per second of 24. So to summarise, in this video we've used a Redwood viscometer in order to determine the viscosity of 10W40 synthetic oil at a range of different temperatures. Once we've established the viscosity in Redwood seconds, we've then used the conversion graph here in order to convert those viscosities into kinematic viscosity in millimeters squared per second, also known as centistokes.